Hey all, welcome to the second video of the CSES series of CSE, and this question name is minimizing coins. This is pretty. This is actually related to the first question we did, and so let's just jump to the problem statement. So if you haven't read the problem statement yet, please pause the video and read it yourself and try this question once. And so yeah. So basically, we have given a sum of money, and we have to generate this sum of money using an array. We have these. We have the this array contains the denomination of the coins, and we have infinite supply of these coins. Alright. So, for example, if our desired sum is 11, we can construct this in. We have to output the number of coins. The previous question was based on the number of ways, but we have to count. We have to output the number of minimum coins used. For example, if the desired sum is 11, we can make 11 by 5 plus 5 plus 1, which requires just 3 coins. So other ways to do this is you can get a sum of 11. You can get a sum of 11 by from 1, 5, and 7, right? You have to get a sum of 11 from 1, 5, 7. What you can do is you can use 11 coins of 1, right? Or you can use 1 coin of 5 and 6 coins of 1, right? Or you could use 1 coin of 7 and 4 coins of 1. Or you could use 2 coins of 5 and 1 coin of 1. And is there any other possibility? I don't think so. Is there is any other possibility? So first way would require you 11 coins. Second way would require you 7 coins. Third one would require you 5 coins. And the last would require you 3 coins. As you can see, this is our answer. 3 is our answer because it requires me the minimum number of coins. We have to output the minimum number of coins. So, sorry. One way is to generate all the possible combinations. The next way is the first way. And this is actually what we will be doing. We would be generating all the possible sums we can generate through these 3 coins, and we would be considering the minimum number of coins required from this. So the constraints are pretty interesting. If you see the number of denominations is up to 100, and the denomination and the sum we want to generate is up to 10 power 6. So my approach here. So let us consider what is the approach here. So you have been given an array, and you have been given these 5 and 7, and you have to construct, and you have to see the minimum number of coins it requires to get the generated sum, get the desired sum. So if we want to break this problem, how would we break it? The one way is would be to take a binary approach here, like if I want a coin or not. But this approach will not work here because this is not a binary answer, right? If you want this coin, then how much coins you want? There is a constraint here. Like it's not like if I would take it or not take it. No, there are there are not two possibilities. There are many possibilities. So what we would be doing here is we would be constructing an array of size n, of size x basically, and we would be breaking our problem to smaller portions this way. Like we have x, right? And if we know that the minimum number of coins required to form x minus ai for some I, right, for some I between 1 to n, if we know that the minimum number required to form this sum, we know that the minimum number required to form x would be 1 plus minimum number required to form this sum, right? 1 plus fn of this, right? So let us see in Sublime here. So if we know that we require 10 coins to generate 10, then we know that if we have a 1 coin, suppose we have a 1 coin, then we know that there, to generate 11 there would be 10 plus 1 coin, right? That would be 11 points, right? So if we generalize this approach, suppose we want to generate x, and we know that x minus ai for some I can be generated, mm, minimum of suppose y points, our x can be generated in y plus 1 points. But there is a little condition here. Uh, there is no guarantee that it is the minimum number of coins. So we would be just creating a min here, min of current number of coins, comma y plus 1, right? So number of coins to generate x, coins to generate x is equal to minimum number of current number of coins, comma y plus 1, right? And this approach, we would be using this approach to solve this. We would be considering an array. We would be creating an array, right, of size x, right? So let us create this array in Sublime, because that's a little bit tricky here to create that array with the mouse, right? So suppose x is equal to 11. We are taking the test case given to us, 1, 5, and 7, right? So initially our array would look like infinity, comma infinity, comma infinity, comma infinity, dot 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 till infinity, right? We would be creating an array of size 11. We all initialize with infinity, got it? And now we would be iterating through all of our coins. So first we will iterate through one and fill out all the possible combinations. So our zeroth coin and possible combination to generate zero coin is one, right? That no, it is zero actually, right? Because there are no combinations in which I can select a coin and create a zero sum, right? So now the next one would be like x is equal to x. So we would be starting our loop with first, right? The one we would be starting a loop with one, and we will be seeing if we can generate one minus one. As if we could, if we will be seeing if we require less number of coins in 1 minus 1. So 1 minus 1 is equal to 0, and we require 0 coins to 0 coins to generate 0, right? So our answer for first index would be, suppose this array is ARR, right? So ARR 1 would be equal to ARR 1 minus 1 plus 1, right? Minimum of, or the minimum condition, ARR 1 comma, right? So suppose so we will be actually naming this array as DP instead of ARR, because it's a DP array, right? So DP1 minus 1 plus 1, this would result into 1, right? So our first index would now be turned down from infinity to 1, and then the second index would be turned down to 2. Why 2? Because we would be interested in 2 minus 1, because we have the coin value as 1. This is the coin value. So basically, for every dpx is equal, our relation is that we would be doing it dpx comma dpx minus ai plus 1, right? So this is our relation for the dp array, right? X minus ai, so a condition, a simple condition here would be that x should be greater than equal to ai, or else we would get a runtime error, right? So I hope it is clear. When I get to 2, I search for 2 minus 1, dp1. dp1 is actually 1, and 1 plus 1 is 2. So we turn down from infinity to 2, and from infinity to 3 till 11. Now for I is equal to 5, we would be doing the same approach. Till 0 till 4, we would be doing nothing, because 4 minus 5 is negative, right? When we get to 5, we now know that 5 minus 5 is 0, and 5 minus 0, and 0 plus 1, basically 1 is less than 5, so we would turn down from 5 to 1. And similarly for 10 also, right? With 10, 10 would be 2. And then for 11, we would then for any other case which would jump from, basically which would require 5, would be created this way, right? So let's jump to code now and see what how do we code this. So I hope the approach is clear to you. So let's jump to code. So first we will be inputting everything, and then we'll be creating a dp array with size x plus 1 and initializing it with infinity. At infinity in my case is 10 power 18. You can consider it as 10 into max also. So dp0, we would initialize our 0th element as 0, and just a second, it is not formatted. This one is formatted correctly. Yeah. So we would be creating a loop from I is equal to 0 till n. It is actually a macro defined here, right? It is just for short notations. And then I would be creating another loop for j is equal to 1, j till x, and then we will adding our reference relation here. And there is a small condition here, because if our last element is infinity, we should consider it as minus 1, that our current sum cannot be generated in any way. So there can be a case, because it is written here. It is, if it is not possible, then we should print minus 1 instead of infinity. So if it is not infinity, then we just output the xth element. Our answer would be the xth element, because that there would we would be showing the minimum number of coins to generate the xth element. So I hope the code is also clear to you. That is also a simple one. And the next question, which is and we will be discussing this next question in the next video. Just a small spoiler to the question. This question is a little trickier than the previous one, but actually very similar. So you should try it on your own, and at least 15 to 20 minutes. So till then, let's have a break, and bye.